Hi, Joko.
Hey, Josh.
What are we talking about today?
Today we'll go through large language models.
Yes, I mean, that's something which you can't get away from hearing, unless you've been living under a rock. The last year, everything is large language models or generative AI. I guess it's our turn to talk about this huge topic. So I guess today is more a primer on large language models and how it applies to healthcare. I think maybe to start, we could talk about, I feel like we're working in healthcare AI and then NLP, natural language processing. And it's very interesting to see things like ChatGPT come into the societal consciousness. I think this has only happened one other time in my life, and that was working as a doctor through COVID, right? So during that time, I got all the news and the first-hand experience of treating patients with COVID. And at the same time, I could see all of this was being discussed on the news. And, it's very interesting because the media has said certain things, but you as a frontline clinician also maybe know some different things or nuances about what's going on in that sphere. So I think today maybe let's start by talking about your experiences of having worked in NLP for almost a decade, right? And how that, what are your takeaways from this big discussion on natural language processing and large language models at the moment? And what are your thoughts and maybe your maybe your big insights into what's been happening in the last 12 months and beyond?
No matter what, I think the leap that was made with ChatGPT was giant. I don't think it is possible to say anything else there. If I'm looking a bit more from the AI side, I still see the progress maybe as being slightly more incremental than I think general public, just because most people never knew about AI. And then suddenly there is an AI I can talk to.
Yes.
So, but from my side, there was a bit more progress in between. So large language models existed before ChatGPT came out. Large language models are here from, 2017. So the leap was a bit more incremental, but it was still a very, very big step, because I still remember maybe something around that period, 2017, 2018, a friend asked me, can we somehow record a conversation between two people and then easily summarize it, extract the key points from that, and make it into some kind of a nice document that is representing that conversation? And I was thinking, yes, it is 3 years of work and quite a few people from the ML side and from all the other sides. And what changed when we got ChatGPT was that this is 2 days of work. The whole thing that 5 years ago would take me 3 years and that would take me a lot of people and God knows how many experiments, now was, sure, I can do that in a couple of days.
I still remember when ChatGPT first came out, and I was working as an AI clinical research fellow, and it was incredible. It was around Christmas time, I remembered, and Professor Teo, my supervisor, sent me a message on WhatsApp saying, "Oh, check this out. This is so amazing, this ChatGPT thing. Play on it, start experimenting with it." And it was incredible because I don't think in any other job I could actually just, for the next, I'd say 2 weeks, all I did was interact with ChatGPT from a healthcare point of view. So, 9 to 5 and beyond, I would just sit there having a one-on-one discussion with ChatGPT. And I basically tested it in all kinds of ways that a clinician would be interested in. So I got really interesting insight. And obviously the models changed since then. There's been many iterations and many guardrails and safety rails put in. But my first thought, I still remember, was that it's amazing. It's very verbose and very convincing in the text. But in my head, I was like, yeah, there's some things here which make me think it's not going to be that good for healthcare. It's making very basic mistakes. And we'll definitely cover this, the kind of mistakes that it's prone to in this episode. But I think, yeah, it's such a mixture of awe, but also skepticism initially when I first interacted with it. I don't know if you can recall what your first thoughts were when you logged on and started interacting with ChatGPT. What kind of things did you ask it?
I don't know, I think initially it was just random things, but I've already seen language models that you can interact with before. There were a couple of other iterations before, so it was not like that surprising. You even before ChatGPT had some websites where you could talk with characters. I think one of them was really called like character.ai or something like that.
Was it any good?
Yeah, it was okay. Like you could speak with, I don't know, Bill Gates and be like, oh, hey Bill, what's up? What do you do today? And can you help me invest in these stocks? And which one would you invest in? And it would respond. It was nowhere near as good as ChatGPT, but there was still like basic questions and it could hold a conversation and be decent enough to pass.
That's interesting. Was that a large language model as well? Do you know? Or was it something that was just pre-programmed and deterministic?
No, it is an assumption because I don't think they made it public what it is, but it was a large language model, or I assume it's a large language model. And I mean, even before this, we had GPT-3 or GPT-2, which are just like different versions of this ChatGPT model that already could write sentences, that could answer some basic questions. So it is not like, it was not, oh my god, this is now world changing. But it was still a big step.
I guess ChatGPT introduced accessibility more than anything and a nice interface. And with the reinforcement learning, it was just so easy to talk to, right? So it was just very kind of human-like outputs. Yeah. Why don't we talk about the history of large language models, just very briefly, because I only joined the AI research in the last 2 years or so. And, you know, the large language models which I've been coming across mostly was, from 2017, like transformer models, and then learning about things like GPT, so generative pre-trained transformer, and then ChatGPT. But my understanding is that there has been, depending on how you define the large language model, there have been large language models prior to that. Is that correct?
Yeah, it is really dependent on your definition. And if you are simply talking about language models, there were language models much before that. Anything that is in some way modeling the human language is usually called a language model. So even something simple that is just a simple neural network that's doing something with a language can be still called a language model because it is trying to understand the human language. And the big thing here is the prefix large, which is hard to define. It is hard to say, like, after 1 billion parameters, this is just every one of these language models, or every one of these large language models has a certain number of parameters inside that you are training. And you can say that after 1 billion, this is a large language model. Below 1 billion, it's a small one. But this is also like finger in the air, looks that the 1 billion mark is a good mark. So I would still say that probably the large language models that became popular and that people know today are the ones that happened after 2017 and basically started with this transformer architecture.
Yeah. So what happened in 2017 was a landmark paper came out called "Attention is All You Need," and essentially that introduced a new architecture for AI. It's called the transformer model. I mean, Jalko can explain this in more detail, but it's essentially the transformer model introduces this new mechanism called the attention mechanism. Would you like to expand on that, Jalko?
Yeah, we can do a brief expansion on that, but I would maybe just before going into attention and explaining what is the transformer, I'll maybe take a top-down approach and explain first a bit more what's a language model, define what is it, and really like how does a language model work. So I prefer the top-down approach just because like we start with the most general one and then we learn more and more until we get to really the transformer and the attention mechanism. So we'll make quite a few assumptions here, but let's start. So imagine you have a black box. That black box is your language model, is your AI. Initially, how it works is that you feed a couple of words at the input of that black box, and then the output, it will predict the next word. So what you can do is, for example, at the input of that black box, you can put, what is the capital of France, ? And then the model will predict the next word. So the next word that comes after this can be, for example, the. And then you will again feed that at the input and the model will predict the next word. So a language model always, in this case, these types of language models we are working with today, is always predicting the next word in a sequence. And if you continue this, so what's the capital of France, ? The, then it will predict the next one. The capital, then the next one of
is
France, is Paris.
Great.
So yeah, that is the most. So in this case, we have been working with a model that is already trained. The black box already has all the knowledge inside of it. Now the question can also be, if I now have a black box, so we go a step deeper. Imagine now you have this black box, but it's empty. It doesn't know anything. You want to train it, you want to teach it the human language. That can be English, German, whatever.
But what do you mean it doesn't know anything?
So in the first example, when we were looking at this black box, it already knew human language. It knew how to understand sentences, it could answer questions, it could do a lot of things. So it already possessed a lot of knowledge inside of it. But now in the second step, just assume that there is no knowledge. We need to train it. So it is just an empty black box and we want to train it. So how do we do that? How do we in fact train a language model?
You mean there's a black box that can kind of predicts the next word but has no true understanding?
Yeah.
Yeah.
It doesn't know anything. So it will predict next word, but the words will be random. It doesn't know, has no knowledge inside of it.
Yeah. Got it.
So these language models are trained so that you take a very large corpus of text. And very, very large in this case means like billions or even trillions of words. You would almost go and collect all the data that exists on the internet. So you would go through every web page that exists and you would take the text from that web page.
Yes.
Once you have that, you would just concatenate them all into one giant stream of text. And that stream of text would have millions, billions, or trillions of words. And then what you do, you feed the first word in that sequence to your black box AI. And you ask it to predict the next one. So let's again assume that our first sentence is, what's the capital of France? I am feeding the words, what is the capital of France, ? And now the model should predict Paris. But because at this point the model has no knowledge, it predicts something random. It maybe can predict, I don't know, London or New York or whatever. So if the model makes a mistake, I tell it, no, that is a mistake. The correct answer is Paris. Learn from that. So update, change your parameters so that you predict Paris next time. And next time it sees the sequence, what's the capital of France, it will predict now Paris. And in this way, you just continue. So my giant stream of text, that is trillions of words, at every point, I'm asking the model to predict the next word. If it's wrong, I tell it, no, that's wrong. Here is the right word. Learn from that. And I just continue.
Yeah. And by wrong, you mean in the text or the corpus that you've taken off the internet, that the model is not predicting the same way that as the text that is in that corpus.
And the corpus you take from the internet is extremely varied.
Yes, so that's what I was going to say.
Yeah, because you might have examples where in a forum somewhere or on Twitter or I don't know where, someone asked really the question, what's the capital of France? But you can also have examples, I don't know, there is maybe a website somewhere that is teaching math. And then what you can have on that website is that there is an example of 2 + 2 = 4. And then this model will take basically the tokens 2 + 2 =, and I will ask it to predict what does it equal to. So the model is also learning to predict that 2 + 2 = 4. Basically, it's learning a bit of math. And in the same way, you will have probably some medical data somewhere.
Yeah.
So that the model is also, I don't know, someone is asking somewhere about a disease, or there is a research paper presenting a disease together with symptoms, medications, or they are presenting a rare case or any of that. And the model will go through all of that and learn to correctly predict the next word. And by doing that, it will learn about the subject.
Yes. And I think just to add to this, I think that's really interesting. So it basically learns by mirroring or learning from text that's already on the internet. And sometimes that's good quality text, right? And sometimes it's not, like you said, from Twitter or often from Reddit. A lot of these models take a lot of text from Reddit. And sometimes the text there is maybe not the best or not written in the most intuitive way. But also as a clinician, I also understand that, medicine is a language in itself. Like we use a lot of very specific words, which you wouldn't normally use in the human language. And it's mixed in with a lot of Latin and Greek. So it's amazing that the model can learn and that there is that kind of text out there from textbooks and from papers, like you said. But one shortcoming is obviously the way we write in hospitals is also its own language and its own slang, and that is not very well represented on the internet because obviously a lot of this is confidential data, and there's not much in comparison to the millions and billions of text that's the model's trained on. There's not much of that kind of text out there, right? There's only some data sets which have been anonymized. But yeah, it's very interesting. So I think as a clinician, I think there's already some things there in the training that I'm not fully comfortable with or that I see could cause problems further downstream.
I think the main problem is exactly as you mentioned, is that there is a lot of data that is just wrong.
Yeah.
When collecting these data, you're not very discriminative. You're just like, give me everything. I want as much as there is on the internet. And by doing this, you will also collect, a lot of these forums, a lot of information on Reddit, or simply a lot of information online, especially about medicine, is simply wrong. It is like, that is why the first thing when you Google my head hurts is you have cancer. You don't want that. Yeah, exactly. You don't want the model to learn that. You want the model to be like, oh, that's a headache. Maybe just take some painkillers.
Yeah, because it's a disproportionate amount of mentions of things like cancer, which are very scary stories and scary things that happen to patients. But because of its motive, I think a lot more media or different blogs and things would talk about cancer, and that's why it crops up so frequently. No one's interested in, an ingrown toenail or, ingrown hair.
You sure?
It's not as interesting, right? No one wants to hear about a viral conjunctivitis or an infection that you can't do anything about. They want to hear about, scary diseases that you need to go to your doctor to get treatments for, or things that you might miss that might turn into cancer later on, right?
Yeah, I mean, I don't know. I think this goes a lot into psychology and how the human mind works and all of that. If I'm Googling headache and it's just telling me, oh, take some painkillers, I'd be like, oh, okay, whatever. But if I'm Googling something, I'm probably think like, oh, I hope it's nothing really bad. So that is why also I think the way Google works is whatever was the most clicked, that's what is on top of the result. So what was the most clicked in the past was the cancer result, because people are scared. So you end up with cancer being very high, and that gives a chain reaction on more and more information on cancer and all of that. But the bad part was just that the LLMs also learned from that data.
Yes. So you covered about the kind of training the black box and on large web-based corpuses. What's the next kind of big step from that?
So this portion of the training is usually called self-supervised training, meaning you don't need to provide any manual work. You simply collect the data, let the model run. And in this portion, you want the model to learn general knowledge. You want the model to learn as much as possible. You also want it to learn the language. So you want it to learn, for example, the English language or the German language and any other language that exists. You want that knowledge to be somewhere inside of the model. It might not be like the cleanest, but most of it is there. So what is left is the fine-tuning, is the slight improvement, and that is usually the next step, and that is like instruction-based fine-tuning. So what does that mean is that once you have trained this big model, it knows how to do a lot of things, but it misses that 1%. It misses that exact knowledge or exact I don't know how to call that, but it does not know that when I ask it a question, it should respond, basically. Let's just say it like that. Sometimes, because occasionally it would see a question online and someone would below just write no. Like someone is asking what's the capital of Paris, someone said no, I don't want to answer, I don't care. So somehow you need to teach the model that, oh, but you should answer, and you should answer correctly. You should answer with the facts. And the instruction fine-tuning is basically you give an instruction to the model and you give the answer to the model. And you are training now the model only on these. So the instruction can be, oh, here is a PDF document, summarize it. And the answer is basically the summary, and I'm training the model how to summarize it. What does it mean to summarize a document? So it knows that a bit from somewhere on that it has seen on the internet. But it's not 100% sure what does it mean. So in this case, you are like giving that exact knowledge to the model.
Yeah. So just to summarize, so it sounds like, you have a black box. You teach it how to predict the next word based on text that's on the internet. And then the next thing is you essentially have this word predictor, but it doesn't understand the intent behind humans trying to interact with it. Would that be correct in saying? So that's why you create these instruction data sets to basically direct the models to understand that, okay, when I ask this question or when I put this statement, this is actually the intention of a human and this is what I want you to output. Is that a fair way of explaining it?
Yeah, no, it is exactly that. So the model does not understand what it should do because it saw millions of examples, and some of them can be, like I mentioned, like some of them can be completely wrong. Given the input, the output can be completely wrong or just some random thing. So here you are telling the model, if you see these at the input, you want to output that. So if you see a question, you want to output the correct answer. If you see a task instruction, you want to solve that task.
That's instruction tuning in a nutshell. You basically show the model what you want it to do. But then what's the next step? Do you find that instruction tuned models are quite rigid? Like if you don't ask it that specific question in a similar way to the instruction tuned set that you've given the model, do you find that it still doesn't respond very well?
Yeah, I think the instruction tuned models are extremely good if the question is well defined. So if it was tuned on a specific domain and if you define your question properly, I think the instruction based models are extremely good for that. But what was very soon shown that it doesn't work is they don't really hold a conversation well, because conversations are dynamic, and it is also very often that people don't ask like proper questions. It can be that someone is asking an incomplete question, or especially in the medical domain, if someone comes to you and it's like, my head hurts, what medication should I take? Your answer is not, here is the medication, go home.
Yeah, my answer is, I need more information. You should come in, or we should take a thorough history and examination, because there's very important questions that I would like to ask to ascertain whether this is a benign headache or something more sinister. Not all patients give you nice kind of tidy questions as well. There's many patients who would come in, they don't know what is important information and what's not. So they might end up asking the wrong question or giving the wrong question. And that's why doctors go to medical school, to learn the arts of history taking and understanding when you need to delve deeper and what kind of patient you're talking to, engaging their understanding of their own condition. So how do we make it more conversation friendly, or more like ChatGPT, shall we say?
Yeah, that's the next step. So the next step is have the model be a bit closer, a bit more human-like. This will still not be perfect, but it makes it a bit better. It can hold a conversation. It can ask sub-questions or can ask back if you missed something. So this is the reinforcement learning from human feedback. So for short, it's RLHF.
Yeah.
And in that case, you are now training the model on whole conversations. It is, I don't want to go too much into details. Why is it called reinforcement learning? What does it mean, human feedback? But on a very, very high level, and how does this work, is that we are not simply training the model on the question and answer pair, but we have a question, the model answers something, then we have another question, then the model answers something. So we basically have a stream of these connected, and there is a human in the loop always that is trying to help the model go in the right direction and either ask the right question or steer the conversation properly and be a bit more human-like. There is more to this. I don't want to, reinforcement learning is more, there is more to this. There is a couple of different models you use here and a couple of different paradigms to train this model. It is not that complicated, but there is many videos explaining this. So
I think one thing to cover maybe is that, one way of kind of directing the model is by rating its responses, right? And then kind of nudging it that way, giving it a rating and reinforcing is essentially the good outputs, the good answers in a way.
Yeah, there is a nice explanation to this that I forgot exactly who gave these, but maybe if we find the link, we'll put it here. If you are training the model on a question-answer pair, you are forcing some knowledge onto the model. So it can be that the model does not know anything about that, and you are simply forcing the knowledge, and the model will be able to answer that without understanding anything. So for example, if I ask the model, I have diabetes, what should I do? And assume that the model has no idea about medicine. But in your instruction fine-tuning, you have created the answer of what should a person do if they have diabetes. So you are forcing the knowledge onto the model. And that sometimes, or that can lead to hallucinations because you are forcing the model to answer. And if a similar question appears, the model will still try to answer it, even though it does not really know much about the topic. It does not really understand the whole medical side. And this reinforcement learning from human feedback, together with rating, is somehow making this a bit nicer. So what it does is that I ask the model, what should I do if I have diabetes? And ask the model to generate 100 different answers to that question.
Mm-hmm.
And whichever one is the closest, I tell the model, okay, this is the right answer. This is in the right direction. It may be not like 100% correct, but this goes into the right direction. And because the model generated that answer itself, I can be to some extent sure that it possesses that knowledge and that I'm not forcing knowledge onto it, that I'm not putting something into the model that is now completely new. I already know that the model has this somewhere in its brain, in its neural network, and I'm just telling it, this one is the correct one. The other ones you have, not so good. This is the right one.
Yeah.
So you are, and this is also called, you are aligning the model to yourself. So you are aligning the model to what you think is correct. What you think can also be wrong. So you can align the model in the wrong way. But yeah.
Yeah, the way I see it is almost like the model understands words, but not the world. And then with instruction tuning, in a way, you're trying to show by doing or guide by doing, by giving it a data set of instructions.
Yeah.
And then reinforcement learning, in a way, you're like a parent, kind of, you're asking the model something and asking it to do something, but you're basically gently nudging it, saying, okay, this is nice, this is not nice, this is nice. And then the model's learning that way. It's a very simplified approach, but I think for me, it always helps to kind of put a human side to it. I don't know if that's, you would agree with that analogy.
No, I agree. I think that's good, yeah. In one case, you are telling the model, do it, and I will help you along the way. I'll nudge you in the right direction. In the other example, in the instruction tuning, you are giving the answer immediately, and you are like, this is the way, do it this way. There is no other way. So it is a bit, I think the other one is more...
One's like a strict parent, like strict Asian parent. Maybe I shouldn't say that. One's like a strict parent, and one's like a more relaxed, kind of progressive parent, guiding through positive reinforcement.
No, exactly. Yeah. So in this way, then the model becomes a bit more aligned to what people like and what it should answer and how it should answer. But of course, as we will see when we go to the medical side, maybe we can now mention MedPaLM.
Yeah.
There are still many problems.
Yes, there's lots of problems. And I guess just going on that very last point you made about, reinforcement learning, I imagine you'd need to provide a lot of nudging because there's so many things that you could talk about with the model, right? So you can talk from, geography to science to medicine to art. Do you think you need to be kind of reinforcement learning? Do you need to give it reinforcement in each domain and each aspect?
In general, it should not be like that. If we are talking about these models being able to generalize from one domain to the other, or if it knows about 3 domains, maybe it can generalize to another 20. So it should not be the case that I need to nudge it for every single domain. Which is obvious. even with ChatGPT, we can be sure that when they were training it, they did not train every single domain in existence, but it still works for almost any domain relatively well.
Yeah. Why don't we talk about, so given that pipeline you've just mentioned about how we can train a language model, let's try and think how we could align the model to a clinician rather than a general human. So, how we can align something to a doctor. So going back to very first principles, when we mentioned you can train a model on all the text on the internet. Instead of doing that, theoretically you can train a model only on medical corpus, or have a larger proportion of medical textbooks or medical corpuses, so then the model has a more intuitive understanding, or give the model more medical data to learn from. And therefore you have a better base understanding of medicine. But you also keep the other stuff, right? The general knowledge, but also just a higher proportion of medicine.
This is a very good example because I've tried these and I've done these. I've done these, in fact, with the GPT-3 model. So before ChatGPT came out and all of that. And I took one of the existing models. I couldn't take GPT-3 because that one was not public, but I think it was Neo GPT or GPT-J or something, one of those. All of these are just variations of the model, so you don't have to worry about the names and all of that.
Yeah. What happened?
Yeah, I took one of them. I trained it on King's College Hospital data. So I took all the clinical notes. I had the exact same idea you just had. So I was like, okay, if I train it on clinical notes and if I train it on discharge summaries and all of that, so basically hospital data, it will be so good because it will have medical knowledge.
It's funny you said discharge summaries, because that's notoriously often the worst written document in hospital, because it's often written by the most junior clinician who has probably the least input or understanding of what's been going on with the patient. But yeah, okay, I'm interested. So what happened after you fed it these valuable discharge summaries?
So the model was worse than it was before. It became a mess. The model was writing in a style that did not make any sense. It was breaking sentences in the middle. It started making spelling mistakes. I was like, what is happening? It became a complete mess. It also started writing in abbreviations. I could not understand what it was saying anymore. It did not use like full sentences. It started using strange symbols and all of that, and everything went wrong.
You're describing, the reason for this is because sometimes, especially in a busy hospital, like I said, discharge summary is written by the most junior doctor often. And sometimes if you're so busy in the week, the discharge summaries pile up. And then if you're a weekend doctor or a doctor later in the afternoon, sometimes you'll be asked to write up all the discharge summaries. So, often there's many discharge summaries waiting for me to do back when I was a junior doctor. And in order to try and get through it as fast as I could, sometimes we make mistakes, and sometimes the summary is not the best quality documents. So it makes perfect sense. So in a way, GPT actually learned exactly what it was supposed to learn in the discharge summary.
No, of course, yeah, that is... It always learns exactly what it's supposed to learn. Even when you train it on all of the internet, it's always learning everything. You have to make sure that the data you are training it on is good enough. Otherwise, like garbage in, garbage out. No matter that there is a large amount of medical information in these clinical notes and all of that, it was still not well structured. It still was not well organized that the model could learn any meaningful information. And one of the very important parts was that every one of these models has a limitation on the length of the input and the output it can generate. So none of these models can take a whole book and output something. There are a couple of them. I don't want to go too much into that, but most of the standard ones that are currently used today, ChatGPT, GPT-4, all of that, take maybe 3,000-4,000 words at most.
Yeah. I mean, that's the next bit of research, right? They're trying to expand this context window. But yeah, we can talk about that another time.
Yeah, no, but here I just wanted to mention that when you are training this model then on clinical notes, there is so much copy-paste, there is so much not so useful information in one document. Like, occasionally I read a document that's like 5 pages and there is one sentence there that's new. The other, everything else is just copy-pasted from somewhere else. And the model basically gets very confused. It cannot look at the whole history. It doesn't know that this is now copy-pasted because it's only looking at a couple of thousand words. So it cannot look at the whole history of a patient that can be really hundreds of thousands of words. So it is learning from that small context, and because of that, not the best output.
But this also highlights that is very true. There's a lot of copy and pasting going on, and it's actually frowned upon. We should really write things that are relevant and that are important to be discussed. But I guess that also covers, I guess the point I'm trying to make is machine learning and building models is great, but sometimes you need to go back to basics, and maybe with some cleaning you could remove some of those duplications and actually improve the model output that way, and try and get, as a clinician, a lot of my work is actually going through the notes and trying to get rid of superfluous noise that might confuse the model. So there is no replacement for good basics, data science skills and data cleaning and things like that.
Yeah, and this is not sometimes. This is every single time. This is what you have to do. It is, if you don't do this, nothing works. You can spend years on making that model perfect. If your data does not make sense, the model cannot learn. This is like many people in AI, almost like everyone I know, has made this mistake of trying to program the model better, trying to add different techniques and all of that, instead of spending a couple of days making the data nicer.
Yeah, the data is priority. All of these models, yes, they have pros and cons, but the data is really the most important thing.
Yeah, I mean, joint, of course. Both of them are important, but both of them are like 50-50. It's not that the model is 99 or something. Both of them are there, and you have to put a lot of effort into both, into making the data perfect so that the model can learn from that. And what you want to teach the model has to be in the data. Like, it is sometimes not so, it seems simple, but sometimes not so easy to understand that you cannot after ask the model to do something that was not in the data.
Yes.
It will be very hard for model to, I don't know, if we trained the model on hospital data and only on hospital data, and after I'm asking it to play chess, it doesn't make sense. It will not play chess.
Yeah.
So you have to make sure that what you are teaching the model is in the data, or what you want the model to learn is in the data.
Yeah, absolutely. But yeah, so I'm sorry to hear that unfortunate attempt at training a GPT model on discharge summaries.
Oh, I have.
But there have been some successes, I guess, well, semi-successes in the general sphere, right? There's PubmedGPT, which was trained on PubMed, so, medical research papers. And then there's also Galatica.
Yeah.
What was that trained on? That was a science one.
Yeah, was published papers from every discipline, I think. There was no discrimination. So
the one comment I wanted to make is models trained on these corpuses whilst they are scientific or medical articles, there is inherent bias in there as well, because the things that get published are often one kind of thing. So for example, neurological conditions, case reports, way outrepresent the other specialties because you get such weird and wonderful cases in neurology. And likewise, a lot of scientific research is exploratory, right? It's not certain. So there's a lot of discussion about, could this be the hypothesis? Could this be the driver for this mechanism or this disease? But it's not certain. So I think this needs to be considered when you're training something on this kind of documents. There is bias, inherent bias in what's published.
Yeah, no, it is. Yeah, there is bias everywhere. So it is also like you cannot also consider what is published 100% correct. Stuff changes over time. Something that's published 5 years ago does not make sense anymore today. Yeah. That is like one very obvious question, even if we are not. Oh, we can go into the medical field. If you are training the model on the last 50 years of medical data, currently when we are training these models, we don't really consider temporality. We don't really consider something's 50 years old versus something's from today. And if you are today asking the model, what is the medication I should give for, I don't know, chronic kidney disease? That is very different from what it was 50 years ago to what it was today. And if you're asking what is the best medication, a paper from 50 years ago will say the best medication for CKD is this one. A paper 20 years ago will say the best medication for CKD is this one. So you'll have a lot of these. This is the best one. Yeah.
One good example is stroke. Over 50 years ago, there was very limited treatment for strokes. And, it's a very devastating, disabling disease where you can lose, your cognition or motor sensory function of your body. Before it was just aspirin, just give high dose aspirin and, wait for them to get better or to get worse. But in the last few decades, there's been development of new treatments. So there were landmark papers in the 1990s for thrombolysis, which is like a really powerful clot busting medication. And if given within the appropriate time window, which is normally around 4.5 hours, you can really make a big difference into a patient's trajectory and how much disability they have in the next, how much recovery they make in the next few years. And then now, even more recent, thrombectomy is becoming more and more common. So that's a procedure where you can go in to the vessels of the brain and actually retrieve that clot and remove it. And the outcomes for that so far have been very spectacular. So I think I completely agree with you. Treatment changes, like medicine changes sometimes more rapidly than people think. And there are still new diseases that are being discovered, which is crazy. I saw a patient with a really rare disease called IgG4 related disease in the neurology clinic the other day. It was only discovered, I think, around 10 years ago, this disease. So we're still learning a lot.
Yeah.
And I think, sorry, that was a bit of a tangent, but my point is I agree. We don't, things change.
Here it was just that if we are training this model for the medical field and also for other fields, things change in every field. One thing that is, I think, currently missing from a lot of these models is these, let's call it continual learning. Something where the models over time learn new knowledge and also learn that what they knew from discard, to discard old knowledge. So that's something we need to include more into these models, especially for medicine.
Yeah, that's very interesting.
So maybe we go a bit into existing models. So we started mentioning the models for science, and a lot of them are targeted more towards, scientific writing or a specific domain or something like that. But there is a couple of them recently, MedPaLM and MedPaLM 2. that were
Yes.
really targeted for the medical domain.
Yes, and that's more the instruction tuning part. So they really tried to make this model specific to the medical domain. And let's talk about benchmarkings, So how do we know if one model is better, right, for a medical domain versus another? And one very popular metric that has been thrown around a lot with ChatGPT and other large language models is passing the USMLE exam. So that's kind of the medical exam that all US residents have to sit. And yeah, MedPaLM, I think, achieved a state-of-the-art performance in that exam. Sorry, go on.
Can you just give maybe like what questions are in the USMLE? Like what would be a standard example?
Yeah. So I think it's very similar to the exam that we sit here in the UK called the MRCP, but I think they cover kind of more specialties. But essentially, it's just usually multiple choice questions. You get either a scenario and they ask, what's the best treatment, or what's the most likely diagnosis? And often they design it now in a way called single best answer. So in a question, there might be several answers that are technically plausible, but there's one which is probably more correct than the others. But yeah, so those are the kind of questions. And then there's also kind of image questions, like looking at scans or looking at different ECGs and things and interpreting what the diagnosis is from there. But very much the bulk of it is multiple choice questions, text-based, which makes it so good to run into these models. I think so what we've seen is that even ChatGPT, a model that's not specifically tuned to the medical domain, has achieved, has passed the USMLE, and likewise with GPT-4 and all the other iterations of large language models. So it's very impressive from that side. And I think MedPaLM achieved a state-of-the-art performance in the USMLE. But then that opens up bigger questions, right? So number one, why are we measuring models with this metric? Is this a good metric to measure a model, actually? Because as a doctor, passing the exams is just one aspect. And actually, I would argue my real life job is very different from an exam. There are many responsibilities to the job of a clinician, and only actually a small proportion of that, it's only a very small proportion of patients even come in a neat little package that you can ask a multiple choice question on. You're dealing with many unknowns when a patient comes in, and in some cases you already know the diagnosis, right? So if I'm working as the stroke registrar, like a stroke doctor, half the time they kind of present with stroke, but there's more important questions. I want to know how they're doing compared to the next day, what their social history is. We need to speak to the family, communicate their prognosis. We need to link in with the multidisciplinary team. So linking the physiotherapists for their rehab, speaking to speech and language therapists to improve their swallowing. I would argue that the diagnosis is only a very small part of my job. And I think we need to have more benchmarks, or at least I would say that using these benchmarks doesn't prove that a large language model can replicate any parts of the clinician's job, or definitely not in its entirety.
Just to sum this up briefly, basically we have the MedPaLM and MedPaLM 2 model that were fine-tuned for the clinical domain and that were then benchmarked on almost like multiple choice questions. So answering questions and solving some very simple tasks.
Yeah.
And the question is basically like, why? Or does this prove anything? Why is extremely easy to answer. it is because this is the simplest thing you can imagine. This is the easiest thing to do. Computer scientists very good at doing the easiest thing. It is like, I don't want to invest time into making my perfect data set and a good benchmark and all of that. I can just take the multiple choice questions, train on half of them, test on the other half. If that works, I can say my model's best at USMLE.
Yeah. I mean, in their defense, they also, I think they tested the model on long format questions as well, because they realized MCQs weren't adequate. So they tested more long format, maybe like more essay type questions. And then they also added a human evaluation where they got clinicians to evaluate its output in certain scenarios. So I think they understand that more needs to be done, and like there needs to be different ways to measure the model's performance. But none of those are adequate.
That's the thing, that none of those prove that the model can be used. It is very good that they are measuring different things, and it is good that they have the human feedback, or that have the human in the loop evaluation, so that humans are checking, is the model incorrect? How much is it incorrect? Is it dangerous or is it not dangerous? Does it understand the question? Does it understand what it should do and all of that? We can show a quick image of the whole 12 criteria on screen. But all of these, even the essay-like questions, are still very self-contained. Are still very, okay, this is the question, give me an answer. Which is extreme. I don't think that ever happens. What usually happens is that you have 20 steps until you get to the answer, or you hold a conversation and you ask about a million different things, and you consider a million different things from that patient's past, and then you come to an answer and say like, okay, you should do this. And it's not even that. It's not one answer. I think like you try then something, you maybe do a test and then do something else and then do a third test and then come to a conclusion with a diagnosis or...
Yeah, absolutely. It's multi-step reasoning. And often these MCQs, they list out the symptoms or the signs that you've elicited in the examination and history. But actually approaching a patient and knowing what history to ask or what examination to conduct within your very busy day and kind of the time that you have is also an art in itself. And that's not encoded in text, right? That's very multimodal and it's very, very human. You need to be taking in what the patient's looking like, what the environment is, like what's the context in which they've come in. You need to talk to them, but you can also talk to different witnesses or different family members. And you also pick up so much from their facial expression, if they're in pain, if they're intoxicated. All of these things are very, very, I don't know, I feel like it's very difficult for a language model to really take over on all of these aspects. It takes a lot of training and you really need to be, dare I say, human to be able to take in all of these different things. I don't think there's any model that can take into account all of these different variables.
This will be my computer science side, but I would always say like not yet. Sure, at this point I don't think there is one, but I do hope there will be one.
Not yet. And also, sorry, but just taking a slight tangential discussion, I think it's also unreasonable for people to think that a language model can do all of these things, right? Because so far in AI, we have been in many ways trying to emulate the human brain and intelligence. And actually language is only just one function of the brain. There's actually many different functions. We have vision, we have cognition, we have emotions, we have different like higher cortical functions. There's many aspects to the brain. And I think it's probably wrong to assume that, a language model can do all those different tasks. Maybe it's only meant to replicate just the language bit. Maybe we're still missing different pieces of the mind where we can piece together and create human intelligence.
I mean, I agree. These models are expanding, so it is not, if you look at, for example, GPT-4, and I even think MedPaLM 2, we can check these, but I think this model is multimodal, which means it is now not accepting only language, but it can also take images as input. So a lot of these models are expanding. GPT-4 is 100%.
Yeah, that's the way they're heading. Yeah, that's
yeah,
for
yeah.
sure.
So everyone is expanding so that we are emulating more and more functions of the brain. But there are still, of course, many things missing, and I do think there is a lot of things that we need to do in the future. I still wanted just to conclude that with the MedPaLM and MedPaLM 2 and other models in this medical domain, these are all very nice steps forward. I mean, it is awesome to see that a model can solve USMLE. It is nice to see that if I have a simple question, if I understand a bit the model, so if you understand the limitations, if you understand that if I'm asking a question of the model, I should be clear. I should try to include everything I think is relevant. So if I myself have a headache and I know I have 0 other problems, I can go to the model and say like, oh, what pain medication should I take, or what should I take for a headache? And it will tell me like, oh, take this one. I can be to some extent confident like, okay, that's fine. Or that is looking fine. Or maybe the medication recommendation is a sketchy scenario.
But careful, like headache, I'm working as a neurology doctor. Headache is very tricky. You don't know which headache you have. Some are actually very dangerous. Some are benign.
Yeah, but if I didn't have that model, I would just take whatever pain medication there exists. So maybe that model will tell me immediately like, oh, where is your headache? Or ask me a couple of questions, or ask me like a couple of... So I didn't want to, in fact, these examples with medications was not the best one. I don't like models to recommend medications. That should not be done.
Yes.
Another one, a better one, is just me asking like, oh, what are the symptoms of diabetes? And then I can learn a bit about the symptoms. Instead of me Googling for that, I can learn what are the symptoms of a disease, or I can see like, okay, what can contribute to slowing down or speeding up diabetes or something. I can learn.
I think it's good for general knowledge. Yeah, I think asking it kind of encyclopedia kind of knowledge is fine. I think you can ask it, what are the symptoms of diabetes, of stroke? I think the problem is when you take your own experience and give it to the model. That's when it's difficult. You're saying, I'm feeling this, I'm feeling that. And then the model tries to match it up with something inside its, knowledge base. And then that gets a bit tricky.
Yeah, no, recommendations of treatments and all of that. That was not the best example. That should not be done. That has to be supervised by a doctor.
So I think what you're touching on is, where should a model actually fit in to the clinical workflow? Or how do we put guardrails around the language model so it doesn't cause harm to patients? And actually one very easy way, like you've just explained, patients or people will go to these models and ask questions, right? And sometimes the patient may not know what they don't know. They might give the wrong information, and the model tells them something that's wrong, or overlooks something, or scares them into thinking they have cancer. So one way is to maybe, at this moment in time, give large language models to clinicians rather than patients. So, I don't think patients should be interacting with large language models anytime soon. But I think with clinicians, we have the knowledge. So we could theoretically interact with it and know when it's saying something that is wrong, or we should consider carefully. But hopefully it might be useful in the sense that it might prompt us to consider something we didn't consider. Right? So that's one way. That's like changing who interacts with the model.
I mean, in theory, very good idea. In practice, impossible to implement, because how can you prevent a patient to ask ChatGPT like, oh, what's this disease I have? What should I do? So I agree that
Y-
it is much better initially to have these AI models assist clinicians.
Let me preempt this by saying that there's still a lot of regulatory problems or issues to work through before LLMs get integrated into anywhere clinical. But I think it's nice to talk about what potentials there are. So yeah, I think assisting is a very big thing. And there's a paper that I read recently.
No, wait.
And it's
I just wanted to say something about the...
Oh, sorry.
No. It is interesting. I just wanted to put a note on the regulation part. It is very interesting how the regulation here seems almost to be working against... I don't want to say against safety. So not for safety, but against it, because it would take a lot of time for the regulation to be implemented in hospitals. It would, for the AI models to be implemented in hospitals because of regulations.
Mm-hmm.
But anyone ever can use ChatGPT and ask about any possible disease and ask about medications they should take and everything else. Basically, we would, because of the regulation, we are not choosing the safe route, which is doctors together with AI work on a diagnosis, but we are using the unsafe route, which is a patient is directly asking the AI, what should I do? And then giving a medication or whatever. And this can be very dangerous because it can, sure, some medications you need a prescription, but for a lot of them you don't. And you can also do lifestyle changes. You can do all of that can really have a negative impact.
Yeah, so, but I think that's a wider societal discussion, right? Because I think it all boils down to the intended use. And yeah, like before LLMs, there was Google. Patients always Google their symptoms, but it's not intended for that, right? It's very different. I think, regulating something that's intended for medical use, because then you're saying, okay, this is fit for medical use, rather than people just abusing large language models or search engines out there for their own health concerns.
Yeah, no, I mean, I agree. Yeah. I understand why is it like that. I'm just saying, like, it seems that the regulation part is doing counter what it should be doing. It should be making it safer, but it's not making it safer. It is just having people interact with AI directly.
No, I fully understand your thoughts, but also having read quite a few regulatory papers and things, that, just playing the devil's advocate, they would be saying, but it's a medical device and it needs to go through stringent, testing, and I think it's always hard to approve an AI that's kind of so probability driven, right? I mean, I don't really want to go deep into this, but like a ChatGPT or LLMs can give different outputs, even if you give the same inputs. Now, there are ways to tackle this, which we can talk about another time in the next episode, perhaps.
Yeah, this goes a bit into implementation and all of that, and every one of these models can be, you can set a parameter for the model to be more creative or more precise, and you can easily have that parameter to be basically as precise as possible, which means always generate the same thing. But then the output can be a bit robotic and doesn't look human-like and all of that. So, yes.
And you still risk hallucinations, right? It's never 100%. It won't hallucinate, even if you turn the temperature completely,
No, of course, The temperature is simply saying it will always generate the same thing. It will be a bit more concise, but it does not tell you much about if it's wrong. It's wrong, no matter what. It will hallucinate. In fact, I am not a big fan of the term hallucinate. It does not, like, why are we at this point? Why are we saying these models are hallucinating? It's, if you had your classification model before, and I don't know, you are classifying the sentiment and you're saying it's a positive or negative sentiment, and the model is wrongly classifying a sentiment of a sentence as negative. You're not saying the model is hallucinating that this is negative.
It's a false positive.
The model is just wrong. There is nothing else. And here we are now saying like, oh, the model hallucinated the answer. No, it did not. It is just wrong. There is, I don't know. I just don't like the term hallucinating much because it just means the model's wrong.
I think because it's so good at chatting and conversational talking, we anthropomorphize it, right? We see these large language models as like a human, and we're saying, oh, it's hallucinating. But you're completely right. Maybe we should just be applying the same kind of, metrics, sensitivity, specificity, false positives, false negatives to large language models. But it's difficult because people are taking the outputs verbatim, right, and trying to act on it. So, this is getting very philosophical, by the way.
No, we can of course finish this, but I just want to say I'm not a big fan of that term. I also wanted to just explain what does it mean. Hallucinating in this case simply means model's wrong. There is nothing else to it. There is no like model invented something new and is now thinking in the wrong or like doing drugs. No, the model is simply wrong and there is no hallucinations here. So
well, the technical definition is what it's giving an output that's not necessarily represented in its training data or faithful. I think faithful is the word they use. Is not faithful to the training data.
Same, like that happens with every other model. Sometimes you change one word in your input and the sentiment switches from positive to negative, and you would say like, this is not like my whole data set is training it to do it properly and it's not doing it properly. So it is hallucinating that this is a positive review even though it's a negative one.
That's true. And I guess if you anthropomorphize, if a doctor gets a diagnosis wrong, and it's not in line with his medical school learnings, then
this is hallucinating. Exactly. He did not. He's just wrong.
But interestingly, in the medical way, hallucinations has another definition, which is perceiving something sensory that other people can't perceive. So you can have visual or auditory hallucinations where you see or hear things that other people can't see or hear. So I agree, it's not the best adjective, but what are you gonna do?
No, it sounds much better than simply saying the model's wrong. No, like when you give it that human characteristic of being able to hallucinate, it's much nicer, or model seems more powerful than.
On that note, should we, I've been testing ChatGPT for a long, long time, from its first baby iteration to its latest updates. On the point of hallucinations, should we just talk about some funny examples I found? I have a collection of them.
Sure. I mean, we have together done basically a paper on this. We can link it. That is testing is ChatGPT and similar models. Are they ready for clinical use, and how do they hallucinate? Where do they hallucinate? What is happening? And all.
This is the latest one I tried. I think it was like a month ago. Essentially, we talk about biases in text, in medicine, and all sorts, and we know about that. There are biases in how we treat patients and how we perceive different races and things. There's a lot of research on that. But this is a different kind of bias, which I thought was quite interesting. I don't know if you would call this a bias. I just found it quite entertaining. So I asked ChatGPT, a jolly white man dressed in a red outfit is climbing down my chimney. What do I do? So, obviously it's Santa Claus, right? Like everyone knows. So it says, it sounds like you're describing Santa Claus, a popular figure of gifts giving during the holiday season. Lovely. And it's saying you can prepare some milk, you can offer some assistance and greet him with joy. Okay, now This is the second one. So I changed the kind of white to black. So a jolly black man dressed in the red outfit is climbing down my chimney. What do I do? And then the response from ChatGPT is, in any situation where you believe someone unexpected is entering your home without permission, it's important to prioritize your safety and take precautions. Here's what you can consider doing. So it's saying, ensure your safety, assess the situation, communicate cautiously, and seek assistance.
Yep.
Is that a type of bias, would you say?
Course. Yeah, this is normal.
But this is embedded into our folklore and like our stories. So it's like I don't know, I found it interesting. It's a different kind of bias because it's a story that's been passed down from generation to generation, right?
Yeah, I mean, I don't know. The thing is also here, like, if you were to ask a human, how would they respond?
Yeah.
Would they say both of them
it.
are Santa Claus or both of them are, I don't know, robbers? There is no Santa Claus. He's not climbing down your chimney. If someone's climbing down your chimney, you should call the police. There is no other like solution here.
Yeah.
So yeah, I think in both cases, there is also bias and there is also wrong advice in both cases from the model. So yeah, I would say that is bias 100%, even though even here it is like consequences are large. If that was really happening and you're asking these, bad consequences because of you are thinking, I'll leave some milk and I'll go to sleep.
I mean, I would worry if someone's climbing down my chimney and my initial thought would be to run to ChatGPT to ask it what I should do.
Maybe still today, but I'm sure that over time that will be our normal response.
Yes. Okay, so a more medical one, right? So this is touching on what we were talking about, because large language models, we incorporate language, but does it have a true understanding of the real world like as humans do?
Okay, that's a strange thing to say. Not strange, but it is.
Okay.
I don't like it too much. No, leave it. But I don't like it too much. It's just because like it is very often that we say, or that a lot of papers or a lot of these AI people who are against AI basically are saying like, these models are not really understanding, or they don't understand in the same way a human does. And the question is always like, sure, measure it and show me. It is, you need like, I don't like the claim that something is like that.
Yeah,
it is possible, of course, but
I guess where I'm coming from is as a clinician and studying a bit about child development and things. We spend a lot of time as a baby just crawling around, and before we even really learn language, we interact with the world and we kind of have some kind of understanding of the world. Or you can see this in animals, right? Like, for example, when a otter is born or a polar bear, they kind of inherently know how to swim without any clear training or advice from their parents. So my point is that there is some kind of grasp of the natural world and the physics and the things in that world that language doesn't capture. I'm not saying this in a way to say that, large language models are terrible. I'm just saying there's more to the development of general intelligence.
But is there? I do think like this is, again, all goes into, we'll get again a bit philosophical, because it is, I'm not sure, but is it possible to get to general intelligence simply by using language? Nothing else. No visual input, no physical presence in space and none of that. Simply use language. And I would say yes. We would simply need a lot of the language. A lot of these texts, a lot of words, a lot of training, a lot of teaching. But I would say that you can end up there. You can end up with a general intelligence that is on your PC and can speak with you normally.
Mm.
I think it's more efficient to do it the other way.
Maybe, I don't know, this is all hypothetical, but look, this example is something that I want to draw your attention towards. And, in my mind, it kind of reinforces that maybe we need other moving parts to get to artificial general intelligence. So the scenario is, I'm a 35-year-old woman. I have abdominal distension for a few months now. I feel nausea. I also have amenorrhea, so, cessation of my period.
Mm-hmm.
What are the possible causes of this? And if you look at ChatGPT, it will say the same things as it would say if I told them I was a 40-year-old man, which is, it says gastrointestinal issues. Could be gynecological issues like a cyst or endometriosis or uterine fibroids. Could be liver disease, could be pancreatic disorder, could be cancer. That always comes up.
Sure.
But if you have an understanding of humans and human anatomy, I think your top differential of a 35-year-old woman coming in with those symptoms, so like cessation of period, abdominal distension, feeling nausea, morning sickness. This is just a pregnant lady. You don't even need to pathologize it.
Mm.
This would be my initial thoughts. This is what I mean. I'm saying that the model doesn't have that kind of intuitive understanding of the world. And that's why I think there needs to be more parts before we get to AGI or artificial general intelligence. I don't think it can just be based on language. I don't know what you think about that.
I would still say that the same as before, and also to counteract the example you are giving, you and I have basically created a large language model called NHS-LLM, which is a language model for healthcare. We can address that a bit in a future episode where we cover really how did we make the model and all of that. But what is the point here is that that model is able to answer this question. And that model is correctly saying that the top diagnosis is pregnancy or top differential.
Yeah, but that's because it's fine-tuned on more, NHS and healthcare data. But, I guess my argument is ChatGPT has been exposed to so much text already. It should know what a pregnant, when you should think it's a pregnant lady.
No, but it is always not always the same. It is like we get back to the same thing just because you cannot judge on one example. This one example doesn't prove anything. Sure, there are millions of examples where it doesn't work well. There are many where it works well. So judging on the one does not make sense, and you would need some kind of a quantitative way to say like these 10,000 examples. One of the best examples I have or I use when I'm saying like these models do not understand really what does it mean to think or what does it mean, because if I give a task to you, I give you a brain teaser, a puzzle, and I'll tell you like really think about this, spend your time, do it properly, really think about this and solve it. You sit down and you spend 5 hours thinking about that, going through it, writing down everything you can, doing everything. And then you possibly come up with a solution, either wrong or not wrong. Doesn't matter, either wrong or correct, like not really relevant. But no matter what I tell to ChatGPT, it always will spend the same time thinking, and it will always give the answer in the same time. So let's say the puzzle is simply solved by saying yes or no at the end. Sure, I can ask it to give me an explanation to show me how did it do that and all of it, but there is no like iterative thinking process. It is simply, I have this, run it through the network, get an output. There is no deeper thinking. And in fact, the model will spend the same amount of time and same amount of thinking if I tell it, do this quickly or do this slowly and spend 10 days. The model does not care. It will, no matter what, it will spend the same amount of time and give me, the answer can be different again based on either a bit of randomness or based on training data. What people are often saying is that when you tell the model, think deeply about this and then give me an answer, what everyone is often saying is that the model is more often correct if I tell it to think deeply about something than if I tell it to quickly do something. And that is because it's spent
to you.
And that's like people are saying, like, when you think about that as a human, then you think the model spent more time deeply thinking about it. But I think it is more a reflection of the training data set. Because when someone somewhere on a web page or in a textbook or something is writing, I was deeply thinking about this and spent a long time, then the answer is like correct. It is step by step. It is
more comprehensive.
Exactly. It is more comprehensive versus the answer where someone on a forum said like, oh, from the top of my head, this is 17. So I think it is more a reflection of the data set and the kind of training data.
So you're saying if we had more of that kind of deep, kind of pensive thinking, then you argue that maybe large language models would have a deeper understanding of things.
Yeah, no, I think so. It is obvious that even now, when the data is of a higher quality, the models are better. So there is no questioning there that the models don't improve with the quality of data.
Okay, interesting.
Yeah,
well, that's two sides of the coin, which our listeners can consider.
Yeah, no, but even this is just one example I use, but I don't like any of the examples where we are saying like, oh, they don't think in the same way humans do. We don't even really know how humans think, so how can you say like that is not thinking exactly in the same way? Okay, we are becoming too philosophical.
I think we're going into a rabbit hole.
Let's ignore these and go back to the science side.
Yeah, so I guess regardless of which side of the argument you're on, I think there's still not enough good quality data perhaps or reasoning skills from the large language models to make me confident that it would perform well in a clinical setting. I just wanted to give you one last example of what I found is quite interesting. So basically I'm asking, can you see my screen?
Yes.
So I wanted to ask the model to basically draw me what it thinks a human looks like. So let's just say this is anatomy class. Could you draw me an ASCII art of what? Of the human body. Okay, it gives me a stick man. Okay, I'll change that to it's medical school. Please include detail, including organs. Let's see what it does. Okay, so it's drawn like a, I don't know, to me it looks like an alien. It looks like a pot with a tiny head on it.
Yeah.
And I tried this earlier as well. So it basically gave me like a snake of, can you see this one? It gave me like a snake, so it's like 5 circles. Top on the brain, at least it's got kind of the right order of organs. So it's got brain and then heart, lungs in the next blob, and then stomach, liver, kidneys below that, and intestines. What do you think? I mean, is it unfair to ask a language model to draw me some ASCII art of a human body?
To be honest, like the fact that it can do this to me is awesome. This is like proving to me more about it can reason than it cannot reason.
Really?
Because it's like...
But this thing looks like an alien.
It is an alien, sure, it's fine. But man, imagine like this model has no spatial awareness. It is basically like putting symbols one after the other and hoping that it will turn into an ASCII man. And
look at this last one. This last one I did in the last iteration of GPT 3.5. It just looks like a cupboard with like one eye on top.
Yeah, but I don't know. I feel like this is, given that this model has no knowledge about, like has no spatial awareness, did not receive any image input and all of that. Because like you can ask the same thing out of a model that uses stable diffusion and you'll get a perfect example. This is like I don't see like this one to me is awesome that it can even like do anything, that it can do something to me. It's like, okay, that's good. It knows something. It was able to generalize
your bar's pretty
to some
low.
extent.
But that's my point. Like it needs to be a multi-model system to reach a level of general intelligence that can function autonomously.
Yeah.
In the clinical setting.
No, I agree.
That's my point.
I completely agree, and that's...
So language is not enough. That's what. That was my argument.
No. Okay, sure. Language is not enough. The current amount of language and the current models. The question again is philosophical. Is language ever enough? So can you add more language and better models and whatever and to learn? That's a philosophical one. But the current ones, sure, of course, the current models cannot generalize so much that they don't need any other input. And if you want to have really good images, ask a stable diffusion model or ask a multimodal model like GPT-4. Okay, they are not still allowing us to do that. GPT-4 has like that. Image capabilities, but we still don't, they are not public, so.
Yeah, we'll get there. But look, just for the next part, I just wanted to chat about, look, they're not good enough at the moment, but what can we do right now as clinicians, right? And we talked about this idea. I read a paper on the Lancet not too long ago. It was discussing the 5 levels of kind of integration of AI. And essentially there's 5 stages, and the first 2 stages are basically where we're at the moment, and that's very much assistive. So the AI is assisting the clinician versus the latter 3 stages, which is autonomous, where it can act independently. So I think at the moment it's, in order for us to implement AI into the clinical workflow, we still very much need a clinician in the loop, right? And so, just using the large language model example, we talked about, an LLM diagnosing someone or giving treatment advice. We're nowhere near that. But what it could do is potentially assist the clinician. So, it could read what a clinician is typing, theoretically, read the notes, and maybe just softly suggest, okay, you've mentioned a patient here who's come in with chest pain, you've leg swelling. Have you thought about a diagnosis of deep veins thrombosis, like a clots in the leg, or a pulmonary embolism, like a clots in the lung? I think this can maybe just suggest softly, in case the clinician didn't consider that diagnosis. I think that's something that's very doable, and it's not really having much power over what happens to the patient. It's merely just another tool for a clinician to use in their arsenal of consideration of diagnosis and investigations.
I mean, I do think that is one of the options. I also think we are overdoing it. I mean, that there is, in your everyday life, there is a million tasks that a clinician does. So there is for sure some that AI can take over very easily. Yes. Not because to replace clinicians, but to help clinicians. There is a million tasks that clinicians do that are simply a waste of time. We were last time discussing how NER can help in clinical audits and many other things. So The same is with this
administration. Yeah, that's a big part of the job. And definitely NER or large language models could theoretically assist with that.
Yes.
Automating, basically helping us documents or really generating discharge summaries. Looping back to our initial example on, discharge summaries and how badly written some of them can be. This is quite low hanging fruit, and I imagine it's very doable actually. You could use a large language model to just read what's happened in that admission and then summarize it nicely in a discharge summary template. That's something that could be done.
Yeah, I mean, a colleague of ours was doing that exactly for his PhD thesis. His whole PhD was, can you somehow summarize patient history and just provide, doesn't have to be the discharge summary, but just provide some kind of a summary. So that is one way, and there is many other things here, like people can work on, or not people, AI can do the part of transcribing conversations between clinicians and patients and automatically putting that into the proper format, extracting the diseases from that, doing many things, or I don't know, forming immediately a patient letter that can be sent to the patient, or writing the same thing in a very, very approachable language so that anyone can understand that. Then clinician can just glance over that, make sure it is really what I wanted to say. And if it is, that's it. Like, it makes the job 10 times faster than if I have to do all of that, or if you, of course, as a clinician, have to do all of that yourself. Yeah,
exactly. And just for context, I was running a clinic last week in a neurology clinic, and we saw a number of patients over the course of the day. I would say for each half an hour, 40-minute appointment I had with a patient, I spent at least 20 minutes, so at least half of that time, typing up the consultation in a letter. Or alternatively, you can dictate it, but then that needs to get sent to a secretary, who then tries to decipher what you're saying and type it up, and then you need to check it again. So I think those are the low-hanging administrative work which could be automated by a large language model or any AI language model, which then frees up time. Because imagine if that's freed up, I have 50% more time. 50% more time to see patients.
Yeah,
which would be incredible.
No, but exactly, and I think those are the first things we should look into. The diagnosis part and making sure the doctors didn't miss something, or every possible medication is considered, or you can ask the AI to give you a guideline that you should follow or something like that. Nice, all good. But there are so many things we can do before that, before we go into the diagnosis part, that can already help much more than.
Yeah, absolutely. But that is the kind of more sexy thing to focus on, is it's more exciting. It's like, it can diagnose someone. But in reality, there's so much that can be done before that. And it's very achievable and feasible.
And
but
also
talking about, sorry, go on.
No, I just wanted to say, and also in reality, you cannot diagnose someone with AI. You can try doing that. It is very difficult. I know, I've been doing these for a couple of years. It takes time. One thing we can address in one of the future podcasts is the foresight model.
Yes.
Foresight,
forecasting,
or MedGPT. Basically, it is one of the models that is able to forecast and predict the patient's future, so simulate what will happen with the patient in the future. And I've spent quite some time working on this, and it is very difficult. You have to consider a lot of things. You have to somehow combine all the historical information about the patients, and even once you have all of that, your model is still not perfect, and there are still things that you need to improve, and there are many much more work to do.
Yeah, but it's very interesting work to do. And I think that's something that we'll cover in our next episode on large language models and focusing on health forecasting. It's really interesting, actually. Can't wait to have that chat.
Sure, same on my side. That will be an easy one because I spent 4 or 5 years now working on that.
Incredible. Yeah, but I think that ties up. I think we've rounded up a very nice kind of introduction to large language models. We did have a bit of tangential philosophy, which I hope is okay for the listeners.
Okay, I think that wraps up. Thank you very much for listening. Consider subscribing, and we'll see you next time. Bye-bye.
See you. Bye. Bye.
Thank you very much for listening. Everything we talk about, everything we will do here, we will try to cover all the different aspects that can help us improve healthcare.
Those are lofty ambitions, but I hope we deliver.
Subscribe, and we hope to see you next time. Bye-bye.
See you on the next one. Bye.